Hi everyone. This is Sai from LetsUpgrade. So let's talk about how to get your certificate. It's very simple. You will see two links in the description. Number one is the place where you have to go and mark your attendance. Marking your attendance tells us like, okay, you are a legit student who have attended this particular session. Link number two is your assignment. This is where your 90% of the priority is. You have to go and submit the assignment that is given to you in this particular session. Once you're done submitting that assignment, we will be evaluating that. We will send you an email. If you get the passing criteria, then only we will give you the certificate on a particular date that is mentioned again in the description. Please check these three things, and this is the way how you will get a certificate from Let's Upgrade. Number one, mark your attendance. Number two, just go ahead and upload your assignment. Check for the email that you have received it, yes or no. What is the feedback that you have received from your trainer? Number three, check on which date the certificates will be released. Thank you. Bye. All the best. Happy learning.
Welcome back, learners. In the last module, we have explored functions, the magic of modular and reusable code. Let us dive deeper into another exciting concept, data structures. Specifically, we will explore two fundamental of the data structures, which is list and tuples. These structures are like containers and they let you store, organize, and work with collection of data. Trust me, you will be using a lot of these in your Python journey. So why lists and tuples? Imagine you're imagining okay. So why list and tuples? Imagine you're managing a group of students or keeping track of your shopping list. Would you create a separate variable for each item? Say A is equals to item 1, B is equals to item 2, or would you not, right? No way. List and tuples allow you to store multiple items in a single variable, making your code much more efficient and organized at the same time. So what's the main difference? What exactly is something that differentiates the list and tuples? Well, let's find that out. Lists. They okay. Lists are an ordered mutable collection of items. So when I say mutable, what does it mean? It means that you can modify, which means you can add, remove, or update elements, or you can say your pieces that goes into the container. You can manage those pieces. You can manage the content which is there in the list, right? So let us quickly dive into hands-on and try to create a list and see the structure in Python, how list is created. So I have my code screen in front of you. I'll just simply mention that the syntax is we need to put the variable name, which is your list name here, followed by an equal to, followed by the square brackets. So square brackets are something which explain Python the syntax that hey, I am creating a list over here, and as simple as that. That's how you create lists. Okay, let us now give a variable name to our list. Let us say we are having a list of students, and we could have any student could be Alice, Bob, Charlie, and so on. So this is how you create list. Now in our example, our list contains different names, which is string. Okay, a list contains, this is a list of strings and each string is a name to us. So even if I write a command like print students, and when I try to run this code in my terminal, python sample.py, you will see in the output I am able to retrieve all the names just by printing a single variable name. So similarly, since list has multiple elements into it now, what if we want to access a particular element? So let us see how we can slice or through our list or retrieve an individual element out of it. So continuing with the same list, we will first understand the concept of index. Okay, So indexing is like a unique ID assigned to each element in the list. So in Python, indexing always starts from 0. So which means that whenever I say the first element, which is Alice in this case, so Alice is stored at 0th index, which is like a unique ID, something like an Aadhaar card of Alice. Okay. So in the world of memory allocation, in the world of how Python stores temporary data, so in this list, if I have to find Alice, I'll have to find the index 0, which is also like a room number in a building, right? So if you imagine a building to be a list and each house to be an element, so we can find each house by its house number, right? So that's how indexing will work over here. And it is an incremental way. The more you add elements, the index keep on incrementing. So the second element which comes into the list. Now remember the element which is coming is second, but index goes n minus one. So index is one. So third element will have index as two, not three, right? So just remember that. That's how indexing is supposed to work. So now if I have to access the first element of the list, so if I print students at 0, it will help me uh, just take out Alice as the output. Whereas if I have to print Charlie for an example, or if I speak in terms of indexing, if I have to print the last element, so the printing can happen not only from left to right, which is from 0, 1 till nth element. The printing can also happen from right to left following a negative order of scale. So minus 1 means the last element, whereas 0 means the first element. Similarly, minus 2 will mean the second last element. So we will go there. We will explain you how these things work. For now, let us try to print the first and the last element of our list. So when I run this program, you see I am able to print Alice, which is the first element in our list, Charlie being the last element in our list. Now, if I add one more element over here, say David for an example. Now, what I will try to do is I'll explain you a little bit about slicing, how we can not just print individual elements out of a list, but we can also slice to produce smaller list. So for an example, if I just want to print Alice and Bob, okay, the first two elements, this is what I'm needing. So when I print students, now I need to specify the starting index. If I just mention one single index, Python by default will understand, okay, a single integer inside the square bracket means I need an individual element. But as soon as I put a full colon right over here, game changes, right? Now it's a new syntax. This is known as slice of a list. We are slicing the list into a smaller component. Suppose if I just want the first two elements. So slicing always works with the n minus 1 principle. So say if I want printing till n minus 1, I have to write index till nth value. So let's take an example and try to see and understand. It's quite simple to visualize it with example. Suppose if I just want to print Alice and Bob, okay, there could have been 10 more elements between Alice and Bob, or maybe I had to just print Alice till Charlie, for example. So the point is I have to look at the index of the last element which I want to be sliced. In our case, we want to slice it till Bob. So Bob is currently at index 1. So which is where we have to basically mention 2, right? Because indexing will always print output till n minus 1. So if I have written 3 over here, it will print me Alice, Bob and Charlie. If I have mentioned 2 over here, it will print me only Alice and Bob. Okay, it will always neglect the last integer directly itself. So if I'm saying 2 over here, it will only print till 1. If I'm saying 3 over here, it will print till 2 and so on. So let us see and try to run this program once. Let me save this file, and this is the output. So this is about accessing elements, accessing an individual element, maybe from the starting point could be 0, 1, or could be from the last point could be -1, -2, or it could be slicing a list. In fact, we could also slice a list from the last element till the third last element. If I take this for an example, and now when I try to run this, let me save it. You see, we get an okay, so the idea is that I'll have to go from third last till the last one. And when I see printing, it will start from the third last element. So for example, in our case, the last element is David, the second last is Charlie, and the third last is Bob. So it starts from Bob, and again it goes with the same logic that whatever is the slicing value mentioned over here, -1, it will be skipped. It will only print till before that. So it will go till second last, which is Charlie, and the printing is done. So that's how the slicing works. We can also mention something like -3 till the end. If we just keep this and try to print it, now it will go till the end. So similarly, what it means is that if I start from 1 and I just mention a colon and I mention no value after this, it will take me till the end of the list. So these are few ways that you can play around with list and take different outputs according to your need and purpose. Now let us modify the list. We will try to change or alter a list a little bit. So for example, if I have to add some more elements into the list, what I will do is I'll just mention students dot append, and on append we will mention, say I want to add Eve into the list. Now let me say I'll print students, and I'll also mention, let me also print the list before adding it, right? So print before append list is equals to comma students, print after append list is equals to comma students. So now when I just try to clear this and try to run the program, you will see that before appending the list is only Alice, Bob, Charlie, David, whereas after appending the list now has Eve into the list, right? So similar to adding components, we can remove components. Okay, so there are two interesting ways through which we can delete or eliminate things from the list. So let us start with the first function, which is known as the remove function. So suppose if I have student, which is the list, and if I say dot remove, now if I have to say, suppose if I have to remove Bob, okay, so I'll just print students after removing the Bob. Okay, now when I try to clear this and try to run a program, you will see that once the Bob is eliminated, we only get Alice, Charlie, and David as the output. So what does this mean is that the remove function takes in the exact value or the element which is to be removed from the list. Remember, we are not talking about the index number, we're talking about the direct value of the element or which element we are removing, right? Similarly, we will see one more interesting method which is known as pop. Okay, so when I use students dot pop, and I'll just mention pop over here. Okay, now I'll run this program once again. Remember that when I'm running this program, I'm recreating the list, which includes Bob, Alice, Bob, Charlie, David. And when I'm popping one, you will see the noticeable change which will happen over here, right? So let us run this program once. So as you notice, basically the list we are creating contains Alice, Bob, Charlie, David. And after the pop is run, we are losing David, right? Which means that pop simply eliminates the last element if we do not explicitly mention any index over here, right? So that's how pop is supposed to work. So lists are great for your dynamic data, which means that your data keeps on growing, modifying. There's a lot of creation, updation, deletion, okay, and read required. So in the dynamic nature, that suppose that you're in production, and people, maybe like you're talking about some e-commerce website, maybe you're talking about some gym membership. So on any given day, on any given week or month, you have different amount of people who have subscribed to your services. People uh, stop consuming your services, maybe they upgrade themselves. So today someone is in the uh, elite membership list, tomorrow they can jump into the pro membership list, if that's how your services are categorized, right? So speaking of which, that lists are really capable of being dynamic in nature, and they handle the uh, data in production very well when talking about examples like mentioned previously. So now speaking of further manipulation in lists, something like sorting or could be in ascending or descending order, are pretty straightforward. There are multiple built-in functions which can help you do that. For example, if I create a list, say maybe scores is the list that I'm creating, and I have different scores, could be 25, 32, 11, 37, 40, and 30 for an example. uh, just a random example. So what if I run scores dot sort method? Okay, now you will just quickly realize what sort is supposed to do for you. uh, for an example, if I just try to imagine what sort can do for you, is basically it will try to uh, sort everything in the ascending order. Similarly, if I do scores dot reverse, so reverse is the exact opposite of what the sort does. It takes things in the descending order, right? So when I try to run this program, you will see that the original list which we have created and the list which we are printing are in different order of sorting, right? So now let us talk about tuples. So tuples is again an ordered collection of items. Okay. Now let us talk about tuples. So tuples are again a collection of items, but this time they being ordered but immutable. So again, immutable means that you cannot modify once you have created a tuple. So let us try to quickly go ahead and try to do some coding around it, see how the syntax of tuple is supposed to be. So for an example, I'll say some tuple. Again, it is very much similar how you declare a list, but only thing is the subtle change over here is the change in the style of brackets. We do not do square anymore, we do round brackets. So remember, Python is extremely sensitive to the type of brackets that you declare. Square being for the list, round ones being for the tuple, whereas curly braces being for the dictionaries. Uh, there are few more ways. Uh, just a second, sir. Sorry. Okay. So remember that round brackets are for tuples, square ones are for the list. Let us try to create a tuple and try to print it. So once we have an example with us, we will simply do print some tuple, and let us try to see what this program does for us. You will see that we are able to simply print out tuple number 1, 2, and 3. So again, as similar to list, if we have to access certain elements, they are pretty much possible. We just need to add the index value. Now, by this point, you should be smart enough to realize that what printing at 0 will do. The slicing or the indexing works pretty much similar to lists. Okay, so something which is at the 0th element will be printed. Similarly, if I do starting from 1 till everything, it should give me 2 comma 3, right? So that's how we are working with tuples when it comes to slicing or printing individual elements out of tuples, right? Okay. Uh, so if we have uh, some gray area between lists and tuple, we are just trying to wonder what exactly is difference when it comes to indexing. They are similar, slicing is similar. In fact, they both are ordered pairs, ordered data structures which hold elements for us. The difference is again in the mutability section, right? So for example, in some tuples, by default there is no functions like append, right? Even if I try to create it, it will throw an error. Even if I have to modify something, say index at 0 should now not hold 1 but now hold 4 for us, and then I try to print some tuple. Now if I try to clear my screen and run this example, you will see that I am getting type error that tuple object does not support item assignment or modification. So similarly, you will see there are no functions which help you alter your tuple, right? Once it is spawned, once it is created in the memory, it doesn't change itself. It remains whatever it is. So for example, if we try to run this, you will see tuple has no attribute like append. So now comes the great question that if tuples are immutable, where do they find their practical applications? So tuples are extremely useful when we have to store some sensitive information which we do not want any type of bug or any type of feature in the application to modify it anyhow, right? For example, if we are storing the values like phone numbers or Aadhaar card for someone, we might want to store it in tuple. So by any chance it should not get modified by any part of the code. Thank you. Okay, just give me a minute, sir. I'll take a break. We can start now, sir. So just for a quick recap, when should we use list and when should we use tuple? So lists being mutable, they are great for dynamic data, which means that things like shopping cart, things like memberships or managing subscriptions, lists are really good at handling those tasks. Tuple, on the other hand, being immutable, they make an ideal fix for solutions like maybe managing the train details, could be like fixed number of seats, fixed number of departure times, arrival times. So these things do not need modification, they remain same, maybe at least for a period of time. So that's where tuples play a great role. So again, let us take a 5-10 minutes break. I'll go through dictionary and sets wala part. Okay. Welcome back, Python learners. In the last video, we have explored lists and tuple. Powerful tool for storing and organizing collection of data, right? Now let us move our focus to few more versatile data structures like dictionary and sets. Dictionary and set allow us to handle data in unique way, making tasks like data retrieval and ensuring uniqueness easier and efficient at the same time. So let us understand. Okay, I think, sir, your the slide doesn't match. It should be why dictionaries and Python insights. The okay, the intro is not correct. Welcome back, Python learners. In the last video, we explored lists and tuples, powerful tools for storing and organizing collection of data. Now let's move on to two more versatile data structures, dictionaries and sets. So dictionaries and set allow us to handle data in unique ways, making tasks like data retrieval and ensuring uniqueness easier and more efficient. Let's dive in. So why dictionaries and sets? Imagine you're building an app that tracks customer orders.
So you might need a way to store each customer details along with their order history, right? Or perhaps you need to ensure there is no duplicate email that exists in your database. That's where dictionaries come into picture, right? So dictionaries let you pair your unique keys with their values, while set store collection of unique elements without duplicacy. Let's explore how they work. Now, the syntax to create something like dictionary is again, you follow with a variable name. So a dictionary is like a real world dictionary, right? You look up to a word, and that word being the key gives you the meaning of that word being the value. So let us first create the word or the variable name, which could be say student grades. Okay. Now, we need to store different student names with their scorecards. Okay. So as I mentioned, even in few of the previous sessions, that curly braces are for dictionaries. Uh, you need to make sure that you follow with a name. Could be like Mary, Sim, John, and so on. And once you store it, you see Mary has 9.1 as the grade, Sim as 8.8, John as 7.5. And if I try to print this, and I try to run this program, you will see that I'm able to access the elements like the key value pairs, right? Each being unique in itself. We cannot have two different Marys in a same dictionary because dictionary ensures that key remain unique. So now further, if you want to dig deeper, suppose we need to find the grade of Mary for an example. So we can simply pass in the key value, for example, that, hey, I want the scorecard for Mary, and let's try to print it. So what we're expecting in the output is nothing but 9.1. And which is there, you can see the output is the 9.1 for Mary. So unlike tuples, dictionaries are again mutable, which means that you can add or update key values at the same time. For an example, that suppose if I have to add one more student, for example, student grades at say maybe Alice, for an example, I want to add that they have a scorecard of 7.5. Okay. Now, suppose if I have to update certain values, for example, a student grades at John. Now, John, if you see previously, has a scorecard of 7.5. What if I want to make it, say, 8.6 for an example? So, this is adding a new key. This is updating an existing key. So you can see how adding a new key value pair and updating an existing key pair works for us. And now we can print student grades. You will see if I clear my code and try to run it, I have Mary, Sim, John being at 8.6 now, and Alice with 7.5. So again, if there is a provision to add or update, there is a provision to delete also, which follows the pop syntax. So suppose if I have to eliminate John for an example, so I will simply have to pass in that student grades dot pop, and I'll have to mention the value of the key. For example, let us pop John out of this. And now let's try to print student grades. So now if we try to print it, you will see we only have two key value pairs left in our dictionary because we removed one of the element. So that's how you delete a key value pair from a dictionary. So let us see a few of the most handy methods which dictionaries hold by default. For example, if I continue with the same example, if I have to just see how many unique students are there in this scorecard report, which means that I have to print just the key names, or maybe I just need exactly values only without the keys. Or if I need a set of both key values to be printed together. So that's where items will come into picture to print both key value only values and only keys. So if I try to clear my code and run the terminal, you will see, okay, I have not saved this file. Let me just quickly save it. And now when I try to run it, you will see that the first time I'm getting the only key names, second time I'm only getting the values. Third time I'm getting a list of tuples, which is a list of key value tuples like Mary, Tim, and John, respectively, right? So dictionaries are really perfect data structure to store maybe data which has unique keys and values, right? So that's where dictionaries come into picture. Now, what about sets to begin with? So set is again unordered collection of unique elements, right? So if you are familiar with the theory of sets in statistics and probability, you might be aware that set do not have duplicacy, right? So similarly over here, no duplicates are allowed. So if you try to create maybe sets, for an example. So interestingly, they also follow curly braces. Now, if you remember, we have round braces for tuples, square braces for the list, curly ones for the dictionary, and interestingly, sets also have the same bracket pattern, but by default, what goes into it is different. It is more like just values. There are no more key value separation like this with a comma, right? So this is not how a set is supposed to be. This is a dictionary. Set only have values. For example, I could have fruits like apple, banana, and cherry. Now, when I try to print fruits, let me clear this out. Print fruits. Oh, sorry. I just have to do Python sample.py. Now you will realize that I am able to retrieve my value stored in the set variable, right? So there are ways through which you can also add elements into the set. For example, if I do fruits dot add orange, for example, and now when I try to print fruit, and if I run it, you will see that along with the cherry, banana, apple, I'm also getting orange in the output. And as you can see, the output is not ordered, which means that if I printed cherry, banana, apple, and after adding orange, you see it is no more in ascending or descending order, right? The sets do not maintain order through their genetics or DNA of set data structure is such that that order is not necessary here. So that's really important. So there are few, you can say there are few operations which are the part of the theory of set in statistics and probability, which is also followed here. For example, we could do unions of set, we could do intersection of set, we could have difference of set, set A minus set B. Well, we could have symmetric difference like set 1, difference set 2, and so on. So such possibilities and powerful operations are also available in Python with us. So for example, if I create set 1 is equals to maybe a set of 1, comma 2, comma 3, and if I create set 2 is equals to again say a set of 3, 4, 5, for example. Now suppose if I have to print the union of sets, so set 1 dot union set 2, set 1 dot intersection set 2, set 1 dot difference, and set 1 dot symmetric difference are few interesting ways through which we can do it. We can also follow the special keywords like set 1 and set 2. And if you use the ampersand and, it stands for intersection. Similarly, if we use minus, it stands for difference. And again, this is for the symmetric difference. So however way you want to take it, if you see, let me clear it out. We know our set 1 is 1, 2, 3. Set 2 is 3, 4, 5. So 3 being the intersection point. Let us try to print our program, right? So once we run it, you see union behaves as it is supposed to, that all the elements are united here. only the common elements in intersection, whereas in difference, we eliminate 3 being common in them and only the difference of set 1 is stored. Whereas symmetric difference eliminates 3 and prints difference, like the unique values in both set 1 and set 2. So sets are really ideal for tasks which want to eliminate duplicacy or compare group of items. So one interesting way to use sets, which I personally have used in few of the uh, programs, though not being the most efficient way, but a quick fix is that suppose if I have a list uh, with certain duplicacies and I do not want duplicacies in my list, I can simply convert my list into set and then set back to list. That way, I'll make sure that I eliminate duplicate values, right? It is as simple as running a for loop and creating a new list without duplicacy. So sets are a quick way to do that for you. Okay, so there is one slide which is about difference in sets versus dictionary. So we cover that and then go for iteration, or we first do iteration. Let's do difference. So now let us understand what's the difference between dictionaries and sets. So dictionaries, as mentioned, they store key value pair, while set only store unique elements. Although at a point they seem to both be using curly braces, but this is highlighting a distinguishable feature, which is that dictionaries are into key values such as name followed by the value of the name, age followed by the value of the age, whereas sets could be something like just unique names or unique roll numbers or unique Aadhaar numbers or could be unique email IDs. So we can use dictionaries when we have to use associative data problems, right? For example, I have to associate your name with your actual name value, or maybe your Aadhaar number with your Aadhaar number, right? Whereas I can use sets when I have to ensure there is no duplicacy. So dictionaries are useful for structured data, whereas sets are useful for uniqueness. Let us now quickly recap about how we can even iterate over these data structures, right? So for example, I'll create maybe a sample list, which is like 1, comma 2, comma 3, and I'll create a sample tuple, could be like, let me use L1, comma L2, comma L3, which is like list element 1, list element 2. T1 stands for tuple element 1 and T2 stands for tuple element 2. Similarly, T3 stands for tuple element 3. Let me also further go ahead and try to create a sample DICT dictionary, which holds key 1 value 1, key 2 value 2, and key 3 value 3. For now, I can just say K1 V1, K2 V2, K3, and V3. Similarly, I'll create a sample set, which is like S1, S2, S3. Now, if I have to iterate over these things, so I'll just say for I, which is like the most standard way to explain or teach a for loop, which means nothing but for an element in that iteratable. So our iterable here is a list. So we are iterating in this part with I. So for I in sample list, first it will take L1, it will print it because that's the task in the for loop. It will go back to the for loop, take the next element, and so on. So if you try to print it, and if you try to run this program once, you will see we are able to iterate over the sample list. Similarly, we can iterate over the tuple. I clear it and try to run it. You'll see each time I'm getting the unique thing. Now, when I have to iterate over the list, let us see how does a simple for loop like this works. Okay, what exactly are the challenges that we can face over here? So I'll say Python. Before running this, let me convert it to dictionary, sample dictionary, and I'll run it. And you will see we are only getting by default K1, K2, K3. And if I add a keyword or a method like keys and I run it, it does the same thing. So remember that whenever we are trying to print for I in the dictionary, it by default is it is defaulting to dot keys as that default method. But if I mention dot values over here now, and now when I try to print it, now rather than going for K1, K2, K3, it will go for V1, V2, V3. And similarly, if I change to items, remember items gives us back both keys and values in the same iterable or the same iteration, right? So if I try to clear it, you will see I'm getting both K1 and V1. Now, if I try to use for I comma j, or let me say for k comma v, for key comma value in it, I try to print k comma v over here. Okay. Let me try to run this once. I'll be able to print individually the keys and values now without having a headache to uh, store them in single variable. I'm able to break it down further into two different variables. That's how we iterate through all these different data structures. Could be in the for loop, for an example. Now, let us have a recap of the session to understand what we have learned till now. We understood about the dictionaries and said how they are supposed to work. Some best practices to follow would be that make sure that we use dictionaries for the tasks which require fast lookup by unique key. Uh, some of the databases in real world also follow this algorithm, whereas we can use sets when we have to maintain the integrity of the data by avoiding duplicacies. Uh, Remember to always choose your variable names in a way that they avoid any confusion and they improve clarity and readability of your code. So make sure that the choice of your data structure actually reflects its practical usage in your given scenario. For an example, if you have to iterate over items in the shopping list, dictionary doesn't sound like a great option, right? Thank you. Okay, I think that works, right? Do you want me to speak that in the next video what we are doing or what? All right. So let us stop for some moment. Welcome back, Python enthusiasts. In our last video, we explored dictionaries and sets. Powerful tool, right, for organizing structured and unique data. Now let us shift our focus on something fundamental and versatile, a type of a data type which is built in Python. It is known as strings. So strings are everywhere, from user inputs to file names to storing someone's credentials like the name, address, or anything. Could be strings or sentences. They all are made up of strings, right? So mastering string operations definitely unlocks a lot of possibilities in text processing world. So why strings matter? So strings are set of unique characters, right? Making them perfect for storing and manipulating text data simply. So whether you're validating an email address or analyzing a document or creating a user-friendly message, could be a paragraph, a sentence, or a word, strings are your go-to tool. Let us start by understanding why strings are and how they are so important to us, right? Let us start with the bare basic syntax of how to declare a string. So in order to create a string, we simply need to put in a variable name, could be like, for say, a name for example, and let us say the value is Python. And suppose if I have to create some more variables such as say a greeting, I would say hello world, right? So that's how you create strings by adding the variable name followed by an equal to, assigning the value of that variable. By default, anything which goes under the curly braces or inverted commas, Python will understand that something in inverted commas is a string. So one interesting way to note that strings follow both the single and double quotes. Okay, so it is allowed to use whichever pleases you, or it can also depend upon the type of inverted or the inverted commas, like the inverted quotes that you want in the output. For example, let us say uh, he would, or maybe I don't want it. So over here, we see that we want single quote to come in the output. So we'll just wrap it in double quotes, and Python will by default now understand that, okay, I have to print it as it is. Let us try to see how this type of variables can be printed. I'll just say print name, and then I'll say print greeting, and I'll say clear and run this code. You will see Python, I don't want it, for an example. So which is where we are using single quotes in the output also. It could have been vice versa. Let us say I wrap everything in single quotes. Now when I try to run it, I have double quotes in my output. So that's the play around between the quotes, right? But the syntax remains same to declare a string. In fact, apart from it, what if we have to print multi-line strings or use maybe like a paragraph? So I'll create a variable by the name of paragraph. And I said this is a paragraph. It is made up of multiple lines and sentences in the output. So again, it follows the triple quotes as a multi-line comment would follow. And after print, we will say print paragraph. We will clear our output. And once we run it, Python I don't want. This is a paragraph. It is made up of multiple lines and sentences. So string is a sequence of characters, remember, which is enclosed in the quotes. You can use single, double, or even triple quotes when it comes to declaring a string. So now that we have realized that we can declare string with single, double, or triple quotes, let us understand that how indexing and slicing works in a string. So remember when we learned about indexing in the list, we talked about that. Suppose if name is say John and Doe, so the index how it is supposed to work. I'll just comment this part. So index is supposed to work like this: that John is at 0th value and Doe is at first index, right? Similarly, if I'm creating a word, say Python for an example, so indexing follows at character level. So indexing could be something like that Python is at 0, Y at 2, T at 2, H at 3, O at 4, and N at 5, right? So that's how the indexing is supposed to work. So for example, if I simply say print word at 0 or print a word at 1, we know exactly what the output is supposed to be if we understand how the indexing is working on strings. So similar to indexing, the logic of slicing remains same. Suppose if I have to slice from 1 till 4, for example, we should already be aware of what we are expecting, which is YTH, the first, second, and third index. Remember, fourth one will not come in the output. So few more interesting ways through which we can increase our knowledge of indexing is that suppose if we want all the values starting from 1 till the end, we just leave it like this. And once we run it, you will see why THON is printed. And what if I say I need from start to end all the values, which is full colon followed by full colon, but at an interval of 2. So this is how you mention the start and the end index, which is the complete from P till N, from P by THON, all the elements of the string, but at an interval of 2. So if I am following it, after P, I should skip Y. I should get T in the output. After T, I should skip H. I should get O in the output. After O, I should skip N, and the iteration should stop. Since this is our list. So if there was Python 1, maybe after O, I would have printed 1 after PTO, and the iteration should stop there. So remember, slicing is incredibly useful for extracting meaningful parts of the string, right? For example, we want to extract the name from a particular sentence. We want to extract certain address from a particular sentence. If the format is known to us, we are aware of certain parts in the sentence, we can extract meaningful parts from it. So Python provides rich set of string methods, which are very useful for common operations. We will part by part try to learn few of them. Let us start with creating one string to begin with. Let us say text is hello, comma, Python. Now let us see just by printing text how it looks like. So at basic value, we have hello, comma, Python with an exclamation mark, H and P being the uppercase points in our characters, right? So remember, apart from H and P, everything is in lowercase. So there are a few methods which are very useful to manipulate the case sensitivity. Suppose if I want everything to be in the lowercase, I can simply use text.lower. If I want everything in uppercase, I can simply use text.upper. So if I try to run this, you will realize that the original output manipulates now to have everything lowercase, and yet in the another printing, it manipulates everything to be in the uppercase. So similarly, you will realize that if I add few spacing over here, suppose I add 2, 3 spaces right over here. Okay. Now, suppose if I try to print, I'll create one more example, say print hello Python text2, say 2025. Now, when I say print text plus text2, okay, which will deliver me something like this. Let me run this. You will see hello Python followed by the 3 spacing that we had in between in this example. Okay, let me just clear the screen once. And there you go. 1 byte spacing coming from the text2, whereas 3 byte spacing coming from the text. We have 4 byte spaces right in between. So this is where we have yet another important method known as strip, which can strip down the extra spaces for us if we include it. So if we are stripping text1 and then trying to run it, you will realize that the additional spaces are stripped down, but text2 has the white space because we wanted to have it since we are not running strip function on it. So if that was the case, if I add one more strip method over here on text2, you will realize that the space after exclamation mark will be gone. So proceeding further with learning few of important methods which come along built in Python, one more interesting way to work around with strings is to maybe replace certain parts of the string, right? So maybe I do not want to say hello Python, I want to say hello world after a certain point. So what I can do is let me remove the spacing for now. I can simply do maybe print text dot replace. I'll replace. So replace takes two arguments. The first one being what you want to replace. So I want to replace Python, and let us say I want to replace it with world at this point. I'm gonna save it, and when I try to run it, you will realize that I'm printing hello world, whereas the value which I stored in text was hello Python. So similarly, few more interesting workarounds to do are, suppose if I want to split the string on certain characters, suppose like we have like maybe John, comma Alice, comma Do, comma Jim, for example. Okay, this is our text. Now, what if we want to create a list of all the names from the string? So we can use a split method and explain on what exact pattern or on what expression are we trying to split it. So for example, names could be text dot split. I want to split on the inverted, or you can say a comma for now to begin with. Okay, so that's what goes into the uh, input, okay, of the split method, that what exactly are we trying to split on. When I try to print names, you will realize that just from a single input text, I'm able to create a list of names by splitting it on the correct expression, right? So similar to split, we have join. For example, we could have maybe a join method running right over here. So let us say we store words, for example, in the split version like this. And what do I have to use join? Okay, so I'll just say print. I'll use the dash in between, and I'll say join names. Okay, so I'll or I could have simply used even join text dot split on, right? So you can simply split the string and join it on the dashes. So if I try to run it something like this, you will realize that I have John, Alice, Doe, Jim coming out like this. So these methods, they really make it easy and the code to be clean, making it much, you can say, easier to transform and manipulate text in real world scenarios, right? So maybe we can work around with combination of different aspects of these methods, like we are using join and split together. We could use strip or split together. And one more interesting feature that we can talk about lists would be the string, talking about the strings would be the formatting, right? So string formatting is again an essential method to create dynamic messages, right? For example, if I have to create a robot, if I have to create a chatbot that greets everyone in a same manner, only thing that changes are the name of whom I'm greeting to, right? So for example, if I have a variable with the name of say Alice, and if I have their age as say 25, what I can do is I can simply print. So in order to make strings dynamic, there are multiple different string formatting options possible. Something like dot format or a percentage symbol, which are few older methods. And one of the most modern and concise approach is to use the f string operator. How does it work is we have to simply write f before starting a string, right? So something like hello, comma, anything that goes in curly braces, Python will now understand, okay, this is a placeholder. This is where a variable's value will come into picture. So I have a variable by the name of a name in this case. So it will print the value of that name over here in the string. And in the age, it will print the value of age for this case being Alice and 25. So if I save this and I try to run this code once for me, you will realize that I'm saying hello Alice, you are 25-year-old. Now if I change this value to 27 and I say Bob, you see I do not have to change my greeting message anytime. I just need to have the variables getting changed dynamically in a production environment. We do not need to worry about it. We simply need to hit with the correct variable values, and the same greeting method can be reused again and again. So apart from it, we can also manipulate certain values, like say for example, if we have float precision could be in 4 or 5 or 16-bit precision, wherever it could be. For example, let's take a value of pi. For example, 3.14, 159, for example, okay, or whatever you want. So if you have to print it only till 2 decimals, what you can do is print uh, pi with 2 decimal precision is equals to. Now this is where we will use the colon followed by a dot 2f, and here if we want we can simply use the so this is again one of the older method to do it using dot format, but you have to convert it into the modern format. We can simply use the f string over here, f followed by the value. So the variable name is pi in our example, so we will just mention that pi with dot 2f precision only. So when we try to run this code, we will see that 3.14, which is we are limiting. We would have increased the precision to 3. And once again, when we try to print it, we get 3.142 in this example. So you see 159 is round off to 142. So these are a few interesting ways through which we can manipulate and use strings in different ways. Now, apart from manipulating the decimals to a precision, or making strings dynamic or replacing certain values, we can also make it more beautiful by adding certain escape characters. Maybe if we want to enter a new line, for example, if I have to say print hello world, comma, how are you, for example. So if I'm printing this, I'm saying hello world, comma, how are you? And when I do /n with along with it, you will realize that now I'm simply using the next line to come into the role over here, right? So that's really an interesting way to understand how we can add new lines. Similarly, suppose what if we have to, rather than just adding a new line, we have to add a certain spacing of tab, right? So on the keyboard, if we use space bar, if we use tab, we know what type of spacing it produces. It's like equivalent to 4 spaces. So /t will also do the same for us. It will add a space of a tab, which is like /t. So these are few of the escape characters. Now, previously I've explained you that suppose if we have to make sure that Python doesn't follow the escape characters, there is an method by r. If you put r in front of a string, it will consider it to be a raw string. And now when I try to run it, okay, let me try to run this clear and run it. You will see that /t is no more treated as an escape character. So that's how you make your strings to work with and without escape characters. So escape characters are a little detrimental, and when it comes to putting in path of certain place, right? For example, if I'm putting C followed by Alice, or maybe like users followed by Alice followed by uh, maybe tabs. Okay, so if I try to run something like this, okay, you will realize that if I do not use the double slashes, /t is considered as escape character. So one way to do it is by using double slashes. If double slashes are not possible, in that case, use the raw string formatter to explain it that /u/t are not to be considered as escape characters. Now let us quickly also at the same time try to understand how we can iterate over strings. Now since, for example, text is equals to this is a string, we know that string also follow the same indexing like any other uh, data structure that we have learned, like list. T will be at 0 index, H at 1, I at 2, S at 3, and a white space at the fourth index. Remember, white space is also a character value which will be available to us, right? For example, if I'm printing text at uh, 4, you will realize I am also printing the white space over here, okay? And if I go from 4 till 6, for an example, and now when I try to run it, I'm using I with a white space. So with this being in our thoughts that okay, this is how indexing is working on a string, we can simply use for I in uh, text print I, okay, and if I try to run it once, you'll see I'm able to print this is string one by one by one, including the white spaces also. Okay, now let us try to create something meaningful out of this iteration. Let us say this is a string, and let us create one more variable known as vowels to begin with. We will try to count how many vowels does a string has, right? So we'll start with a counter, vowel count, and we'll say for I in text, if that I is equivalent to a vowel or for a character in text, if characters in the list of vowels, then we will simply append or increment the vowel count by 1. If not, we do not even need to mention that part of the loop. Now remember that this is case sensitive. So since this particular example will not hamper it, but it is always safer to go with dot lower if you want to compare it with lower values only. So, okay, A, E, I, O, U. So I see there are 3 different I's in this example. And now if I try to run it, okay, I also need to print the output once somewhere. So I'll say print vowel count. Okay, and let me clear out. And now when I try to run it, Python sample.py, I'll get vowel count as 3. So that's how we go into iteration. We can also use the reverse iteration if we want, right? So simply we have to use certain methods which are built in for Python, and we can work around with strings in many different ways. So let us say we want to, for example, reverse a string to begin with. So we will say reverse text is equals to, one way to do it is everything in reverse fashion. This is one way to get it reversed, and the other way is reverse text is also is equals to, we can use inverted commas with join reverse as a keyword. Both of them will do the same purpose for us. For example, if I try to print reverse text over here for us, you will see something which is completely funny and in a reversed way, right? So that's all about strings. So that's all about strings for now. Remember the golden rule to write a readable and self-explanatory code remains with the same principles. That is to make sure that your variable names are meaningful. For example, if you are creating a variable which will store address of someone, make sure that the variable name is something like address itself to begin with. Also, make sure to avoid excessive concatenation of loops, right? Like we can use short words like join. For example, if we have to use a for loop for element in string dot split maybe and then join them, we can simply use the join keyword. This will make your code more cleaner and readable. We can leverage the string methods to solve certain complex operations quickly. So make sure that you follow good string management practices to write clean and efficient codes. Uh, so for the next module, we will focus more on learning how object-oriented programming works. So see you there. Thank you for staying tuned in.